So in today's video, we are going to be solving the last question that we are going to be using to understand the basic concept of mutually inclusive events. And we have just one question right here, so let's go into it properly. So the question says that in a class of 32 children, 16 have a skateboard, 12 have a bicycle, and 17 have a scooter. It was also mentioned that 5 of them have skateboard and bicycle, and we have 7 of them to have skateboard and a scooter, and then 4 of them have a bicycle and a scooter. So the question I went on to say they all have at least one of these 3 things. So what is the probability that a child chosen at random from the class has a scooter but not bicycle? So the best method to solve this question is to use the concept of Venn diagram. If you need more information how we are going to be using the Venn diagram to work with this question and using the set theory, I will be linking a video in the top right corner so you can just quickly check that out. So that being said, let us use the concept of set theory and Venn diagram to solve this question. The first step is for us to extract out all the details we have in our question. The universal set simply represents the sample space of the experiment, and in this case of ours, we have a total of 32 children. So that means our universal set mu is going to be equals to 32. So we have 3 events right here, that is a student having skateboard, having bicycle, or having a scooter. So I'll be using SK to represent skateboard, I'll be using BI to represent bicycle, and I'll also be using SC to represent scooter. So let's say the number of students that actually owns a skateboard, that is SK, that's going to be equals to, we have 16 of them. The number of students that owns a bicycle, we have that to be equals to 12 of them, and the number of students that owns a scooter, we have that to be equals to 17. So the question says 5 of them have a skateboard and a bicycle. So that means the number of students that owns both a skateboard and a bicycle, there are actually 5 of them. So we have the number of SK intersection BI to be equals to 5. So the next detail is we have 7 of them that owns a skateboard and a scooter. So that means that the number of students that owns SK intersection SC, we have that to be equals to 7. And we have 4 of them to own a bicycle and a scooter. So that means we can just simply say number of SC intersection BI is actually equals to 4. So the question says that they all have at least one of the 3 things. Simply implies that there is a chance that a student or a child can have skateboard, bicycle, and scooter. So that means it is possible for these 3 events of having either a skateboard, bicycle, or scooter to occur at the same time. That simply means our experiment is going to be producing mutually inclusive events. Taking a closer look at our question, we can realize that the question did not mention the number of children that owns the skateboard, the bicycle, and the scooter, and this is a very useful information since it was mentioned that they can have there's a chance that they can have the 3 of them. So that means I'm going to introduce that into my question and assume that the number of students that owns the skateboard, the bicycle, and the scooter, I'm going to assume that to be equals to X because it is unknown, it was not stated in the question. So after having these details, the first step is for me to use the concept of Venn diagram to actually pictorially represent all of those details. So that means I'll be using the Venn diagram to tell a story about all of the details I just extracted. So please remember that the rectangle represents the universal set and the circles represents the given set. So let's quickly do that. So we have 3 circles. So with the first circle right here, so we have the circle, we copy this circle and then we paste it to have another circle. So we bring this right here. We can decide to color grade this and give this lesser red, and then we copy this and we paste this, and this is a third, and we can decide to call this let's just give this a blue color. So that being said, we need a rectangle. The rectangle represents the universal set, so we have to draw a big rectangle right here, and then it gets to black. All right, so the black circle represents the number of students that owns a skateboard, so we have skateboard right here. The red marker represents the number of students that owns the bicycle, so we have bicycle right here. Now the blue marker represents the number of students that owns a scooter, so we have scooter right here. So the next step is for us to put in the necessary details into the Venn diagram. So this region right here represents the region that a student have the scooter, the bicycle, and the skateboard. And as you can see from the details we have from our question, we were not given the number of students that owns the scooter and the bicycle and the skateboard, so I'm going to assume that to be equals to x. So let's take this away and represent this region as x. So x represents the number of students that owns the scooter, the bicycle, and the skateboard. So this region right here represents the number of students that owns both the scooter and the bicycle. But as you can see, we already have x being a fraction of that region, so that means the number of students that owns the scooter and bicycle only is going to be equals to, we have 5 minus x. Very important. So the next detail is the number of students that owns the scooter and the skateboard. So the scooter and the skateboard region is somewhere around here. Is everything right here. So this is the number of students. So this is the region rather that represent the student that owns both the scooter and the skateboard. But as you can see, we also have x taking a bit of space, so that means this region right here is going to be 7 minus x. And the next detail is going to be scooter and bicycle, and we have 4 of them, so definitely here is going to be equals to 4 minus x. So please note that the universal set is going to be equals to 32. Very important. So we have to work on the necessary region. So we have this region, we have this region, and we have this region. So we need to get each of the values. So the number of students that owns a skateboard, we have 16 of them. So the circle black is represented by 16, but we already have some regions here. We have 5 minus x, we have 7 minus x. For us to get the remaining region, we're going to be performing simple algebra. So the total area or the total region of skateboard is actually equals to 16, but we have 5 minus x, and 7 minus x already taking some space. So that means that this region right here, which I mark with the question mark, is going to be equals to skateboard only. So we can just call that skateboard only. So we can take this to the left. So the number of children that have skateboard only, so we have a skateboard only. So the total region is 16, so we have 16 minus, so we sum all the individual regions we have earlier. So we have 5 minus x plus 7 minus x. So we have 16 minus, we open the bracket, so 5 minus x plus x gives us 0, so we have 5 plus 7 minus x. So we have 16 minus, so 5 plus 7, that is 12 minus x. So when we use the minus sign to multiply the bracket, we have 16 minus 12 plus x, and that gives us 4 plus x. So the number of students that own skateboard only is actually going to be equals to 4 plus x. So that means that this region right here is going to be equals to 4 plus x. So the next region is for us to get this number of students that own bicycle only. And as you can see, the number of students that own bicycle, we have that to be equals to 12. So that means that the region of bicycle only is going to be equals to, we have 12 minus, we have this bracket that says 5 minus x plus 4 minus x. So this is 12 minus, so we have 5 plus 4 minus x, and then we have 12 minus, we have 9 minus x. So we have this will be equals to 12 minus 9 plus x, and that gives us 3 plus x. So the number of students, or the number of children rather, that owns bicycle only, we have that to be equals to 3 plus x. So we write this as 3 plus x. So this is 3 plus x. And for scooter only, so we have a scooter only. The number of children that have scooters, we have that to be equals to 17 minus. So we have 7 minus x plus 4 minus x. And then we have 17 minus, so we have 7 plus 4 minus x. So this is 17 minus, we have 13 minus x. And this is 17 minus 13 plus x, and the final answer right here is going to be equals to 4 plus x also. So when we put this here, so we have here as 4 plus x. So now that we've gotten the necessary region, the next step is for us to get the value of x. And for us to get the value of x, we need to use the basic set rule that says the sum of all the regions must be equals to the universal set. So that means that each of the regions, their values must be summed up to be equals to 32. So we're going to be having 4 plus x plus 3 plus x plus 4 plus x plus 5 minus x plus 7 minus x plus 4 minus x plus x is going to be equals to 32. So let us add up all the numbers. That's going to be equals to 4 plus 3 plus 4 plus 5 plus 7 plus 4, and that is going to give us 27. So x plus x gives us 2x, 2x plus x gives us 3x, 3x minus x gives us 2x, 2x minus x gives us x, x minus x, that gives us 0, so we have plus x left, so this is plus x, is actually equals to 32. So when we do the math, we have x is equals to 32 minus 27, and that gives us 5. So that means 5 students actually owns a scooter, a bicycle, and a skateboard. But that is not what the question asked of us. So the question says, what is the probability that a child chosen at random from the class has a scooter but not a bicycle? Now the formula for that is going to be equals to probability that a child chosen at random has a scooter but not a bicycle. It's equals to the number of children that owns a scooter but not a bicycle divided by the total number of children we have in that class. And from the details given to us, we know that the total number of children in that class is actually equals to 32 of them. So we are only left with getting the number of children that owns a scooter but not a bicycle. If you pay a closer look at the sentence, it says a child chosen at random from the class has a scooter but not a bicycle. We are only interested in those children that do not have a bicycle, meaning there's a chance that this children or this child can have a scooter and a skateboard, but the main point is that the child does not have a bicycle. And the region that represents the children who owns a scooter and not a bicycle is going to be this region right here. That is the region of having a skateboard and a scooter but not a bicycle. So the number of children that owns both the scooter and a skateboard but not bicycle is going to be equals to 7 minus x. And when we do the math, we have 7 minus 5. So this is the number of children that actually owns a scooter but not a bicycle. That is, these children owns a scooter and a skateboard but they do not own a bicycle. So the probability of a child owning a scooter but not a bicycle is going to be equals to 2 divided by 32. And when we do the math with our calculator, 2 divided by 32, that gives us 0.0625. So that means that we have a 6.25% chance that if a child is chosen at random, this child is going to have a scooter but not a bicycle. If you learned something new in this video and you actually enjoyed this video, I would really appreciate if you can give this video a thumbs up and also subscribe to this YouTube channel. Thanks for making it to the end of this video, and we see you in the next one. Bye for now.